Okay, for the sake of the live stream that a few of you might watch, we're going to be talking about some surface modeling stuff, more advanced surface setup stuff that might be useful to you as you build your hand tools. And we've got really only about a half an hour today, so I'm probably not going to get through building this entire set of Fisker's shears, but I will try and set up two different ways of building the handle geometry here to give you guys a fighting chance at building handles at home. At home. Okay. So I have my calipers. Normally I do a little like sketch series trying to think about how I might build these surfaces, but I'm going to jump right in for now. So we're using student version of Solidworks. I'm going to start a part file, and I think the first way I'm going to try to build one of these is with surfaces, and specifically I think I'm going to use, where is it, this boundary surface tool here. A boundary surface is cool because you can build sketches in a number of different planes, connect them with some control lines, and get a relatively complex surface geometry that's easy to edit after the fact. It's also pretty easy to break, and I'll talk about a couple, I guess, things to watch out for to make sure that when you're setting up a boundary surface, it resolves for you all the time. So, all right, these are the Fisker shears that I'm talking about, and like so many things, I'm going to start with a sketch, and I'm going to start with just like the rough profile outline of one of these handles. And these handles are not very well defined. They've got like weird lumps and things in them that I think just have to do with like weird material quality differences. So I'm gonna like try and make these shapes a little bit nicer maybe than they are in real life. We'll see how it goes. Alright. So I'm going to start with a center line that kind of goes the length of my handle, and this is just more of a reference point for me. I guess the measurement that I'm going to take here is roughly the length of the handle that I'm going to build, and I'm going to probably build this handle in two different sections and then mirror something and add a third section later, and that'll become apparent as I'm building this thing. So it looks like I've got about 93 millimeters there, and that's just what I'm going to put in here. Notice I put this on an angle, 93 millimeters, because I'm not sure what angle I want this handle to be at just yet. For now, if I wanted to fix that angle so that things don't move around, I could throw in another line and like dimension this angle here, call it 74.99 because it's not actually something I measured, it's just an arbitrary number. And now I'm going to go about like trying to define the outside of this handle. And for reasons that you'll see later, I'm going to use two different lines to do this. And I'm probably going to use a style spline. So from the bottom, I'm going to start by just approximating the shape of this handle sort of as best I can. And I'm actually going to end it at the top here. So I'm going to like draw a line, make it coincident to this other line, and also add a relation that says make them perpendicular. That is something else that will come in handy later. I'm going to make sure this outline of my handle is coincident with like the edge, the thickness of this handle, and I'm going to use this construction line to actually give myself a dimension from the center of the handle to like the edge here, which again I'm just going to approximate for now with my calipers as it looks like about 10 and some change millimeters. 10 and some change millimeters, cool. Okay, now this is a rather organic shape, and I can either find a way to just kind of play around with these control points till I get something that looks reasonable. One other thing that I might be able to do to give myself a reference is sort of a soft dimension, which would mean, like, let's say halfway up this handle, I'm going to draw another perpendicular construction line and take another dimension on my handle here from the middle. It looks like it's about 9.2. So that's supposed to be about 9.2 millimeters. Rather than add a relationship here between the line and this point and say, like, make it coincident, I know that design splines tend to behave a little bit more nicely when they're not tethered to other pieces of geometry. So I'm just going to move these points around until I get that surface pretty close to where it's supposed to be. Okay? Just something that's kind of a way for you to measure and approximate a line without making a hard dimension that can sometimes over-constrain a sketch. Another thing I'm going to do down at the bottom here is make sure these guys are perpendicular so that if I zoom into the bottom of this handle, I've got a nice tangent point. Like, this line is tangent to this construction line here, so when I connect it to the other part of the handle, they match up nice and flush.
What did you click on to make it perpendicular?
I clicked on, the question was, how did I make those perpendicular? I shift-clicked both of these construction lines. One is like the center line that I built in the beginning, and the other is a line that happens when I make those like design splines. So you can click both of those and then add that perpendicular relation. The nice thing about a design spline is all of these lines are dimensionable. And if you need to dimension something, I would recommend you adding dimensions to these these construction lines as opposed to dimensioning the actual curve itself. Okay, so that's one side of this curve. I'm going to make the other side of this handle as well with another style spline. Notice how when I drag this out this time, it's giving me a suggested relation of keeping everything tangent. That's fine. That's actually what I want. The other side of this is more of a curve that looks something like that. With a style spline, once you're done placing points, if you hit escape, it'll get you out of that tool and leave the line that you have in place. So same thing here. I'm going to make these guys merged and find a dimension here. Because I was dimensioning from the middle, I'm going to just leave these as the same dimension for now. But down in the bottom, it looks like this line, this extra construction line, which I still want to be perpendicular to my center line, might actually be a little bit off-center. I think it's actually a little bit thicker to the inside of this handle. Again, this is not the only way to build a handle, but this is one way that I can set up the right reference geometry to sort of control the outer shape of my handle from the front view. So that came up 10. And it looks like actually I'm pretty close here. I might... Oops, I'm still in Dimension Tool. Why don't you want to move? I don't know. That's weird. Come on, line. It should be allowing me to drag this around. Oh, none of them are letting me drag it around anymore. Let me get out of this sketch and rebuild and save. Do all the other things that you're supposed to do when SolidWorks starts misbehaving. And actually, where do I want to save this? Oh, yeah, that's a fun side project. That would be even more fun, maybe. There's this Fiskars shears demo. Sure. Okay, let's go back into this sketch and see what's going on. Any ideas, people? That's interesting. Maybe I hit a random button that prevents me from moving stuff. Well, you know what? It's close enough for me for right now. SolidWorks is just being kind of silly. So I'm going to leave it for now. So that's basically the design splines are going to let you kind of tweak the shape until you get something close to your handle profile. And point of reference, I'm only building like from here down to start. The rest of this geometry I'm going to do is a different kind of feature. It's because, I don't know if you can see this in profile, the handle is actually a lot fatter here than it is here where it connects to like the metal part of the shear. So I'll use a different feature to build that. Okay, so that's my side sketches, and I might actually label that sketch like master side handle sketch. Master sketching, working from a master sketch is something that I've kind of alluded to in the past. We're not going to dive into that just yet. That's something we'll talk about later on in either this semester or next semester. The idea that you can put almost all of your sketch details in a single sketch in the beginning and then copy that sketch, different components from that sketch, and make features sort of independently. We'll get into that. That's why I'm like labeling it master sketch. It's just a habit. Okay, another thing that I'm going to want to do, so I have my side profile. I also want to build a, I guess my front profile. I want to build what the side of this handle looks like if I'm looking at it from the side view. So I'm going to make a new plane because I actually want to draw like right from the middle of this handle. So I'm going to make a reference plane that kind of goes right through. Like I want it to be cut, like bisecting this handle. So I can pick a line that goes through that plane and a point. I guess I can, let me try something else. Try this line and that point. Okay, and you see how that plane is like right in the middle of my sketch? That's what I'm looking for. So there's my new plane, and that's what I'm going to sketch on. Alright, so I'm looking at, see, I'm like kind of looking at the inside here. I'm going to use, and this is important for a boundary surface, I'm going to use the same number of lines to draw the other profile, in this case like the side profile of my handle. The same number of lines for the side profile as I used for the front profile of my handle. Boundary surface likes to map one entity to one entity, or two entities to two entities. If, for example, I used 2 lines to make this curve and only 1 line to make the outside curve, when I went to actually build the surface, boundary surface is just not going to really like that. Same goes for lofting. So the rule of thumb here is kind of try and use the same number of lines for each side of your surface. Okay, so I'm in this sketch. I'm going to use another style spline down here, attach it to the bottom, and my side profile is a lot more regular, so let me turn this to the side so I can see what's going on. I'm going to use that point up here as a reference point for where the end of my surface is happening. By using the same point, the same reference here, I'm making sure that these points that eventually are going to be the edge of my surface are in the same plane. That's going to make it easier for me to add onto the surface later. And then down at the bottom here, I'm making sure that my surface ends at the same point that, I guess this sketch ends at the same point as my other reference sketch. I will try and make this horizontal. Yeah, now it's letting me move things. I'm probably going to throw another center line or construction line in here at the same point as these 2 construction lines, so I can take a dimension. And this handle does not look asymmetrical. Oh, yeah, actually it does. Okay, so I'll measure from like the peak point here. It's like 9 millimeters one way. And then on the other side of the handle, it's actually more than that. Figure out. So anyway, one thing you might be noticing, I've done a bunch of sketching and dimensioning already, and I haven't even started making a feature yet. There's a lot of setup that can go into making a surface that's complex geometry. A lot of it goes into the setup, but the beauty of doing a lot of setup is in a single feature you can kind of get a really complex surface part like you would find in these handles. Okay, so I'm going to drag these handles around until I get basically what I want here. That is going to be the same. Millimeters. I might look at the front here and make, it looks like it is wider on the bottom like that. Okay, and once I'm happy with that curve, I can just leave it. I'm going to use another spline on the other side to define the other side of this curve. Make sure the bottom is horizontal so that these two, like the curves on the bottom, line up. Build in another center line in the top, or construction line in the top. Make sure it's horizontal. Make sure that point and that point are coincident. Make sure that is the same dimension as the bottom in this case. Get it close, and this one's actually a little bit flatter, like that. Kind of a weird looking handle. Alright, so let me get out of this, and I'm going to save again. Alright, do you guys kind of see the edges of this surface a little bit? There are a couple different ways we can use these edges to make surfaces. And actually, I might be able to show you a couple of them right here. Cool. All right, I'm going to start actually with a lofted surface, which is something that you've probably already had a chance to do. So actually, let me change the title of this. This is my master front. Oh man, I have those backwards actually. This is actually from the front. Okay, save. All right. Now I'm going to do something. I'm going to actually copy parts of these sketches to use in my surfaces, just to make my life easier. So I'm going to build this handle in two different parts and then mirror everything over. I'm going to build the surface that kind of bridges the gap between this and this, those two lines, and then I'm going to build a separate surface between here and here, connect those two surfaces, and then mirror everything over. So first I want to just copy these two sketches and make sure they're on the right plane. So I'm going to make a sketch on the front plane. I'm going to convert that entity, just that one side, onto my sketch, and then get out of it. So I've got like an extra part there. If I hide my front sketch, see, I just have that one line. And I'm going to do the same thing with this half of this curve too. So I'm going to sketch on the same plane that the sketch I'm copying is on. I'm going to convert that entity. Oh, weird, I must have clicked the wrong thing there. Let me delete that. There we go. I've got the curve. I think I picked the construction line the first time. And get out of my sketch. I can hide my master sketch. Cool. There are my two edges. Let me save just so I have this saved. All right, let's try the first one as a lofted surface. So I'm going to say I want to loft that curve to that curve. And that's what it gives me. Now, there's something wrong with this. It's not round, right? It's making a straight connection between those two lines. There are a couple of things I can do to fix that. One is by changing what are called the start and end constraints of my loft. If I open this secret menu that says start and end constraints, I can say I can choose the option normal to profile. And if you see, it added this little pink arrow here. It's making every point on this surface that touches my line here normal to that line. So sticking straight up from that line. It's like it's tangent to, I guess, what would be the section of this line. And if I choose that normal to profile for both curves, see how it's changing that into an actually like a curved surface. That's one way that you can do these kind of surfaces. And if I want, for example, to like lessen the influence of the normality of this line, I don't even know if that makes sense, but I can like adjust how much these things influence my surface. And I can kind of see that like the surface gets a little bit spiky, like pointy down at the bottom. So I can mess with these lines and make that all better. So I'm just going to leave it at 1 for now and say OK. And there's part of my handle surface. Cool, right? Pretty easy to set up once you have your dimensions in, once you have those lines, the kind of the shape that you want them to be. All right, let's try another way to set up this surface. So I'm going to show my 2 master sketches again that have those lines I need to use. And I'm going to create another surface. So I'm going to do the same thing. I'm going to convert those 2 lines into 2 brand new sketches. So I know this is kind of redundant, but I'm going to say, yep, I want that curve. OK, get out of that sketch, hide my master. And now I want that curve. Oops, I guess that curve. So I'm going to sketch on this plane that I created. It might be easier for me to hide this surface really quick so I know that I'm picking the line and not the surface edge to convert. Either would work, but I want the sketch line. Let me get out of that, hide my master sketch, and there are my 2 new lines. Okay, let's try this one as a boundary surface and see what happens. All right, direction 1, and then it wants a direction 2. It's going to give us something really, really weird. And that's because a boundary surface actually needs a completely closed profile to resolve. Right now, I have 2 lines, right? This purple line and this blue line, but I have nothing actually connecting the top of these 2 lines. So I don't actually have enough information to create a boundary surface. So I'm going to get out of this and show you the sketch that I would add to make this surface resolve. And you guys will see that adding the extra sketches that I'm going to do will give me a lot more control over how this surface looks. Specifically, like how pointy it is in between those 2 edges. My lofted surface, if I go into my surfaces menu, kind of gets a little bit pointy. You can see it's like pointy here. I don't want it to be pointy there. A boundary surface will give me more control over that edge. Okay, so I'll show you what I'm talking about here. Let me show my master sketches again. I'm going to hide these ones that I duplicated for now because they're just redundant at this point. I'm going to build 2 guide curves. And they're things that are going to help my boundary surface resolve. So one of them, I'm going to have to build a couple new planes. One of them I want to be right up here in the plane that's sort of like the top of my handle. Right? So I'm going to sketch on here what the shape of my handle is supposed to be. So I think for simplicity's sake, I want it to be just a regular old curve that is, and I'm going to build a couple construction lines here. I want that to be horizontal. I want that to be vertical. And I wonder if it'll let me make them both tangent. Maybe not. Tangent. No, okay. It won't make them both tangent because this is actually an ellipse, not a circle. So let me pick a different kind of curve here. Bear with me for a second. We can do, I guess I could do an ellipse. You know what, I might just do this as another style spline. And say I want these to be tangent. Oops, that was caps lock. Or collinear, that's fine. I want these to be linear. Okay, so now I have this curve in place. It's connecting these two dots that were not connected before, and I made sure that the edge of this curve is going to be tangent across my, eventually like the middle of my handle, and it's tangent on this side as well. All right, let me get out of that sketch. See kind of what I built in place here. It's like the top curve here. That's all I need for a boundary surface, but I'm going to actually add another one down in the middle of my handle here that kind of matches where these reference curves are. So I'm going to add another reference plane right in the middle. Okay. And then I'm going to sketch on that reference plane. I'm going to use the same curve. And actually, I'm going to click sort of off the surface for now so I can make sure that that edge pierces, what is that extra dimension? And that I have, you know, I'm going to hide this surface so I'm only like intersecting with my sketch over here. Make sure this line and this dot intersect, or I make pierce. Oops, I clicked the wrong line because I was in perspective. Let's try that again. I want that line and this to be pierce. There we go. And then I'm going to use some reference handles here. Actually, I can probably do it with this. If I say this, I want to be horizontal, and make sure it's tangent this way, and this one, I want to be vertical. Okay, that worked too. Okay, so as you can kind of see, I have a little bit more structure built into my surface. So I've got two edges that I dimensioned, and now I have two of these guide curves, these extra things that are going to help the surface behave the way I want it to behave. All right, so let's hide those master sketches again. I'm going to show the copies that I made earlier. All right, and that's sort of like the scaffolding for my surface right now. All right, let's try a boundary. You know what, I'm going to save. Try a boundary surface. So direction 1. A good way to think about directions in boundary surface, it needs two directions. One direction would be everything that's sort of oriented in the same position. See, and that kind of looks like a loft right now, but it doesn't have the curve. Direction 2, I can pick these two guide curves and see how it already has, it's like built in the curve that kind of matches those two guide curves into my surface, which is really cool. Another thing that I can do in these boundary surfaces, again, just for added control, is say that I want, let's see, a normal to profile to apply to both of my direction 1 curves. And that's going to make sure that my surface is tangent. Or I guess it's not tangent, it's normal to the profile of these curves. It's going to line up with other surfaces that join on those lines. So normal to profile is okay. I'm just going to say okay. All right, there's my surface. And the lighting is still kind of hard to tell, but you can see that it's not as pointy. It's much more round. It's actually following those guide curves that we built in as an intermediate step. And if you compare it to the other one, it's just a little bit closer to what I actually built. It's closer to my sketch. So that's two examples of how you can build parts of a handle, and it will work. I could use a boundary surface to create this front surface. I just have to build in those two extra like reference sketches. And I could have used a loft to build this back half as well. Both are equally okay. One just happens to give you a little bit more control. Okay, so I've got two surfaces, and that's going to be a pretty solid way for you guys to build pretty much any handle that you find. Yes, you're going to change like the curves to match whatever handle it is you're building, but after you have these two surfaces, there's another step that you can take to make this a complete handle. So I'm going to go to my surfaces menu if it isn't already open and say knit surface. this is a tool that lets you add two surfaces or knit two surfaces together. I'm going to say, yep, these two surfaces, make them one surface. And if it happened the right way, up in my surface bodies, I should only have one surface now. Before that feature, if I roll back, I have two surfaces. Now I have one. They're the same surface, which is good. And I can kind of use the lighting inside SolidWorks to make sure everything looks like it's lining up. Side note, there's another cool surface or cool evaluation tool in the Evaluate tab called Zebra Stripes that will give you this striped environment to check your geometry and make sure things look like they're a smooth transition across this face. You can do horizontal or vertical stripes. It'll give you a good idea of how the curvature of your object is looking. This is a tool that comes from the automotive design world. They would actually set up vertical or horizontal lights in an environment to carve surfaces on cars and make sure everything is nice and smooth. So anyway, you can turn it on, you can turn it off. Okay, so back to surface stuff. I have half my handle. Eventually I'm going to mirror it, and if I want to check, I can actually do that here too. In my feature tab, I should be able to find mirror. It wants the middle plane, which happens to be this front plane. And what do I want to mirror? I might pick bodies, so I can pick that surface body and say, okay, I can say knit surfaces, and it will automatically combine those surfaces into a single surface. That might be what you want to do. And there is the handle as I have it right now. All right, that should get you, those techniques should get you most of the way through most of the handles that you might need to build. I was going to do one other kind of surface so that you guys can see it, using a loft to sort of translate from one handle geometry cross-section to another one. So in this handle, this front handle, it goes from this kind of rounded cross-section to a really flat and narrow cross-section. I'm going to use the loft to make that cross-section happen. This other one kind of stays the same section all the way through, so it might be something I don't actually need to do to this handle. Alright, I'll show you what I'm talking about. Alright, so I'm going to go back to the front plane and make a new sketch of what this handle looks like. I'm going to use a couple lines, just like we did before, and make sure everything sort of lines up here. So this kind of comes up and then dives out in this direction. And then I've probably going to want to add a dimension here that says keep those things tangent. When you make lines tangent like that, it means that the surface is going to translate without a bump in it. The other part of this surface does something a little bit weird. It starts here, kind of dives in, jumps out, and then ends up up here somewhere. I'm going to put a line in between these two and sort of figure out what angle I need that to be at. I might, as construction, come up here, make a line to the middle, and then, let's see, I can probably make those collinear and dimension this angle. This is something I might add for my own sanity, so I know where the middle of this object is supposed to be. I did not make that point attach, so I'm going to go in here and make sure that they line up. I'm going to make sure that these are tangent, and then tweak these so that it looks closer to how it looks in real life here. It's got this weird bump in it. And it should be fine. Well, you'll see. These design splines are nice because you can always go back into a sketch and change them later. Okay, probably something like that. Let me get out of that sketch. And just like before, I have like a front profile, a back profile, and unlike before, I'm going to use a different kind of way of making these two things match. So I'm going to title my sketch something else. This is like the master front handle top sketch. Sure, just for my reference. Alright, I'm thinking of this one as another loft, only this time I'm going to try and loft like this circular profile to like a slotted profile up here. And if I look at my object, like you can kind of see where this orange is, it's like a slot. It's like a tall, narrow slot shape as opposed to a rounded handle shape. So I need to build that in as well, which means I might need to build another plane up here. That's another reason why I like to build these like center lines, is it gives me a nice construction point to use for a plane. I'm going to sketch on here, and why don't I just do this as an actual slot? Sure. Like 1, 2, 3, and I purposefully didn't line that up so I can actually manually make sure that everything is lining up by adding my relations. For some reason it doesn't like that. These two lines should be parallel. Oh, weird. Alright, you guys see what I see here? Like, the plane that my sketch is on isn't matching that line. I kind of need that to be on the same line. And I think I know why. So I'm going to get out of the sketch really quick and fix it. I'm going to go back into this sketch and make these perpendicular, because I didn't do that before. Now I think that should fix it. Let's go back into this sketch here. Yeah, now it's like lining up exactly with that sketch. Okay. For some reason it doesn't want me to pick like just that point to make a relation, so... Sorry? Yeah, and I think... Oh, cool. Clear that. Let's try... Just... Nice. Okay. That's a neat little trick. Cool. Forever I've been not doing it that way. Solidworks likes to treat arcs as like this magical, like, it's almost like a block that you can change. Another way that you could do that is like build in a tangent like construction line and then make that coincident with like this other line that I want it to be coincident with. But nice. Learn something every day. I'm going to try and pick I didn't get the point here. Well, maybe I don't need to because it is technically the midpoint here. That's fine. I'm going to dimension how wide my slot is supposed to be. And that's something I can take a dimension with using my calipers. It's like 7 millimeters. Okay. Let me get out of this sketch. And then the last sketch I think I need is going to be on another plane. I guess I have this plane. Oops. Sketch. And I can convert the entities like the top of my surface here. Now this is kind of breaking a rule, and we're going to see if I can get this thing to resolve. Right now I've got 4 curves making up one profile of my loft, and I guess this is 4 curves, like side, bottom, side, and top, making up the profile that I want to like translate to. Let's see if this works out. So let me get out of all of my sketches. I'm going to save and try to make a loft here. So I want to try and make this as a surface. You'll know there's a loft for making a boss or base, like a solid part. There's also a loft under surfaces. I'm trying to make this as a surface right now, so I just want to make sure I pick the right loft. All right, one profile is that sketch, and I wonder if it'll get me the whole sketch. Yep, it did. And then the other profile is this thing. It's looking okay. It's kind of warpy. And now I need it to follow these other guide curves. So down here I can pick guide curves. Yeah, just that. And that guy too. Yep. Cool. That actually is looking okay to me, which kind of surprised me, but hey, when it works the first time. I do want to, same thing again, like try and make, yeah, I thought that might break it. Alright, never mind. Yeah, it doesn't like those. I like to try and make my lofts normal to the profile. In this case, that would mean like trying to make sure the surface as it comes out of this circle on the bottom comes out at a very normal, like straight angle. The reason it wasn't working is because my curves for the bottom of this surface aren't actually perpendicular to that plane. If that didn't make sense, it's something I might go back and fix right now. Let's see how this thing resolves really quick. Okay, so there's the top of my handle surface. Now, if I go to the like zebra stripes, not curvature, zebra stripes, and let's turn off my sketches, and let's turn off the planes, and just see how that looks. It's actually pretty close. You can see how these stripes kind of spike from this top surface to the bottom surface. That's because it's not exactly a smooth transition. That is something you can control. It's possible, and there are a couple ways you could do it. I could knit these surfaces together, say okay, and then try and fillet that edge. And let's just see if it likes it. 10 millimeters, probably not. Let's try like 2 millimeters. Maybe if I pick more of it going around the edge. It looks like it's trying to do it, but it's not quite resolving. Let's try a smaller fillet. No, I don't think it likes that. Let's try a face fillet. From there to here, all the way around. These zebra stripes are not helping. Oh, I can't turn them off. Cool. We're gonna do chord width. You guys okay?
Everything's fine.
Everything's fine.
It's so fine. Yep, okay, fillet monster does not like this way. So I guess I can go into like the other way to fix this, but it's already 8:40. Wow. Time flies when you're watching someone do SolidWorks. Someone should have said a time check. I could go back in here and like make sure all of my guide curves are perpendicular to that plane. For what you guys are doing, I'm probably way in the weeds here. For your like sketch models, it'd be nice for you to like try and attempt to set up some of this stuff. But this is probably going to be a more helpful reference guide for you as you get into like actually building the handles of your model over the weekend. So I'm going to stop the demo here. I guess what we've covered, a couple different ways: lofting, boundary surface, mirroring, and then using another loft to sort of change profile from round to slot shape is giving me a pretty close representation of what this handle looks like. And if you guys want to come up and see this and see like kind of what it's mimicking, that might be a cool thing to do on your way out. So let me just save this. And are there any questions before I like kill this rendering that you want like in here as a reference? No? Yeah?
Can you explain why you're building a surface instead of a solid?
Sure. That's a good question further out, I guess. Why am I building this as a surface instead of a solid? I've found that when I'm creating something that is like a complex organic shape, it's easier for me to like knit surfaces together than it is to try and knit solids together. That's pretty much the only reason. Because I built this in like 4 quarters on the bottom and then did a loft on the top, the surface tools give me a little bit more control over like the geometry in each one of these as a surface than it would as a solid. You could do it as a solid though, and I'm sure there are a lot of ways that you could like, there are a lot of other ways you could do the same thing, like building this as a square extrusion and using a bunch of fillets to try and approximate the shape of this handle. That's fine as well. But now you have another like set of things that you can try. And honestly, for like really complex surfaces, this one's like very blobby looking, but other surfaces like this guy, the back of this handle, building it this way is going to give you a lot of really good control over exactly how this thing, wow, it's on, yeah, exactly how it looks. Cool? Okay, guys, thanks for sticking around extra late. I'm going to kill this live stream.